I think we're just at the beginning of understanding migraine, which I think portends a very bright future. I was just getting up, it was 8 o'clock in the morning, and I rolled over and I picked up my cell phone and I looked and I saw a letter. And I read it again and I put the phone down and I lied in bed for a minute thinking, could this really be happening? I picked up the phone again after 5 minutes and I went into the next room where my wife was and I said, Mary, guess what? And Mary knew already in her mind. She guessed what the letter had said.
The primary motivation is that it was an amazing discovery. To find a mechanism and then a potential treatment for migraine. Migraine is not a killer disease in the way that cancer or stroke is, but it's incredibly common and lots and lots of people suffer from it. So we thought that that was a really important step forward and wanted to celebrate it with the Brain Prize.
Teenager, around 14 maybe, when I started to get migraine. It started slowly, started to feel strange in the head. First it was the whole head and then it went off to the right side of the head, about here. And it just got worse and worse, and I tried with the usual painkillers but nothing helped. And when I moved my head or when I moved just like any part of the body, it felt horrible, it was pulsing, and it felt like as if someone tried to push my eye out of the head. I remember that I was kind of scared of these headaches. I didn't know what it was, but when it went off, you know, life goes on, you tend, luckily, to forget things. That was not good. But I had a lot of days at home from school because I had this headache, but I thought it could be, you know, you're a girl, you have your periods, things happen, it might be PMS, what could it be? And yeah, I didn't really know.
Yeah, it's beautiful. Well, the predominant theory of migraine, which rose out of the 1930s and also out of the use of drugs that have a very powerful constricting effect, was that during the painful phase of migraine, the blood vessels were dilated and swollen, and that the action of the drugs to relieve the migraine headache was to constrict these dilated and pain-filled blood vessels. What I noticed in the clinic, and well reported in the literature, was that migraine often involves one half of the head. and switching sometimes from side to side. But the pattern of the pain often went right up to the midline and not beyond, which was much more characteristic of nerve than blood vessel pain. And this launched my study into finding out what's the relationship between the nerves that invest the blood vessel and blood vessel behavior and pain.
When I was a student, when I was around 18, 19, 20, somewhere, I tried to find an explanation to this headache and something to cure it. And I remembered I thought it might be from the muscles, that it was the tensions in the muscles that made my headache. So I went to a physiotherapist, and she tried to help me in different ways. And on her wall was a poster with information regarding a study of a new migraine medicine. And she pointed at that and she said, I think you should join that study. But I don't think I have migraine. But I think you have migraine, she said. Okay, I can try. And even though I didn't have any diagnosis, I was a part of this study. And I was so lucky because I got the active substance and it helped me. I had still my migraines, but I could cure them pretty fast and I could go on and I could finish my education. I met my husband, I got my 3 kids, started a working life. And then about 5 years ago, when I was around 40, the medicine didn't help as much anymore. And one day it got even worse. I started to get symptoms that I haven't had before, and I didn't at all think it would be migraine. It started, I couldn't speak really well, and half of my face was hanging down. And you think of a stroke, but I'm not that old, and could it be? But we called the ambulance anyway, and they came, and I got into the hospital, and they made a lot of checkups on me, and finally I felt the normal migraine feelings. And I said, I think I have a migraine. And they said, well, this could be the migraine. But it was really scary. And what will I do the next time I feel like this? Should I just say, oh, it's just migraine? And what if it's not? And well, that made it more difficult.
During 1980, then we discovered substance P as one of the signals in the trigeminal system. And people worldwide were thinking this was the key molecule. We continued, and then we found 1983 CGRP. Our research soon showed that it had a very abundant expression in the trigeminal ganglion, and there was a lot of sensory fibers storing CGRP.
I first met Lars Edvinsson in the summer of the northern summer of 1985, June the 21st actually, midsummer. He gave a wonderful presentation about the protection of the brain circulation with the trigeminal system, demonstrating that if there was a trigeminal lesion, there was prolonged vasoconstriction with noradrenaline. And he talked about neuropeptides as signaling substances. I'd been working in migraine in Sydney, working in the experimental side, and we started a conversation about how to explore these new neuropeptides, how potentially to try and identify substances in the trigeminal system, the pain system, that may have implications, may even be therapeutic, have a therapeutic target in migraine.
At this conference, Peter asked me, is there anything I can do to help you to show that this is important in migraine? And then I told him that my dream was that we would look into migraine patients and see if CGRP is released in migraine attacks. So it took us some time to be ready. I mean, Peter went back to Australia to talk with his professor, Jim Lance, and I had to make the method available for how we can measure the release of neuropeptides in the blood of patients.
The evolution of the CGRP story in the work I did with Lars Edvinsson has three parts. The first part, we were able to show in an experimental setting and in human setting that you could release CGRP when you stimulated the trigeminal system. And we could reproduce it in the laboratory. We thought that might be the right direction. In the second part, we studied migraine patients and at the same time developed our model of stimulation of dural pain-producing structures. And we saw only CGRP release in both settings, human and experimental, but not substance P, which was one of the things people were talking about and excited about at the time. And we thought we were pretty much on the right track then. Lastly, when sumatriptan became available, the serotonin 1B, 1D receptor agonist that people now use in migraine, we were able to show that part of the effect of sumatriptan, and it turns out to be an important part, when migraine was stopped, was to normalise CGRP levels. And I think by that time, we knew we were on the right track.
In principle, we found that migraine with and without aura, cluster headache, chronic paroxysmal headache, and some other headache forms, they show release of CGRP, and it's associated with the pain in the migraine attack.
I suspected that CGRP might be interesting in migraine. I was already a professor of neurology here in Copenhagen and worked at a hospital called Gentofte Hospital, and I had a relatively small group that was working at that time already with provocation of migraine attacks in migraine patients. And we were looking for substances that we knew were present in nerves around blood vessels and substances that could dilate blood vessels. And CGRP was one such substance. And we used it then in our provocation model and gave it to patients. And then we discovered that it can actually induce a migraine attack in people who already have migraine, while in normal control persons, it would just cause a small headache, not a migraine-like headache.
And to date, what we've had largely are just symptomatic treatments, from paracetamol on to other drugs that can kind of alleviate some aspects of the intense pain of migraine. But what they don't do is reduce the frequency with which they happen. And what the drug that was developed, the CGRP antagonists, which act on precisely the mechanism that's been discovered is happening in the brain, do is they reduce the frequency that these attacks happen.
After I had this stroke-like experience, I contacted the doctor again, saying that I have these very frequent migraines, and also this happened to me, and we started to discuss if something else could be done than the triptans that I have. And then he said that I might be a candidate for trying the new preventive medicine, and I wanted to try it, of course. I got the shot, and I took the first shot, and totally amazing. I had no migraine for a whole month. It helped immediately. That was nothing I had expected. And it was like I woke up every morning and said, no migraine today? No. And then the next morning, none today either. This is too good to be true. And it was, because the migraine came back, but with a lower frequency. But it was so good to get that pause in this and not be afraid of taking too much medicine and knowing that it's fine. When I think about this now, about what the medicines have made for me in my life, what they have meant, it's amazing what they have meant. What would I have been and what would I have done if I hadn't had these medicines? Well, I guess could I have been working? No, I don't think, not as I do anyway. Would I have managed with 3 kids? No way. I think I would have been at home in my bed like half the time. What a life would that be? I would have had a lot of pain and been scared, and no, that wouldn't have been much of a life. So I think even though I have these migraines and it stops me, slows me down for a while, and I have to consider different things, avoid some things, but overall, I think I'm lucky. I'm so thankful for the medicines that exist, both the triptans and this preventive medicine that makes me possible for me to have a life and to do all these things that I like to do and to have my family and my kids. That's all I can wish for.
Well, it's not the easiest of professions going into research because the steps that are made and the gains that are made tend to be incremental. And the reward and the feedback often take years to realize. So in the migraine field, it took 30 to 40 years before we realized that the principles that we were working on were applicable to the human. But along the way, there are a lot of struggles. There are a lot of blind alleys. There are a lot of disappointments. But the successes and the gains along the way far outweighed, in my case, the disappointments that are only natural when doing the research.
Research is a series of steps forward with several steps backward, a lot of disappointment, and a lot of hard work. We started out with the idea that we wanted to study neuropeptides. So the first thing is to get the collaborations right, to be able to actually measure the substances we're interested in. That's difficult, very, very difficult, and people still struggle with the CGRP measurements. The second thing that's very difficult, probably one of the most difficult things, is if you have a really disruptive idea, people hate it. They really don't like it. So one of the most difficult things was to actually get traction that what we were doing made sense. And it wasn't till we studied, I think, migraine patients and reversed the effects that really got people's attention.
I think this is a very important part of the story that I think is going to play out in the next decade. And that is, how does CGRP play into the whole pathophysiology story of migraine? We know that it's an essential target for the treatment of most migraine attacks, not all migraine attacks. But what we don't know is where is the site or sites of action, because there are many opportunities for CGRP that's stored in nerve fibers and released when that nerve discharges, many opportunities for interacting with surrounding cells and tissues, including blood vessels, immune cells, mast cells, a whole variety of different panoply of opportunities for CGRP. And we need to nail down exactly where this is.
In a way, it was very surprising that CGRP antagonism works for migraine attacks. Because, for example, we had already studied the effect of CGRP injected intradermally, and it doesn't cause any pain at all. And still, of course, it seems to be so strongly involved in the migraine mechanisms. And the big puzzle is, no, Why and where does it work? We still don't know.
Actually, there are two aspects that puzzle us and our colleagues, of course. Where and how do these anti-migraine drugs act to take away the pain? The second is actually, why are there 3 women and only 1 man? And our current project is try to find out how do the sex hormones regulate CGRP and CGRP receptors. And we have made astonishing findings that these neurons in the trigeminal system, they contain estrogen receptors, progesterone receptors, and oxytocin receptors. But it remains for us to understand how they regulate the CGRP system.
For me, I have a migraine with aura, so I lose part of my vision when I get a migraine attack, and then the part of the vision that's gone keeps growing, and then when that finally stops, the headache comes on. And the headache is usually on one side of the head or above the brow, and it feels like someone is like stabbing you in the head or burning something. Yeah, it's really horrible. And then I also get nauseous. So I have to go and throw up, and you get so weak from everything that's happening, and I try to eat something, but then I just throw it up again. So it feels very hopeless while I'm having it. And then once it finally stops, it's like the best feeling in the world, because you feel like you can finally function again and do stuff again.
Understanding why women have a larger prevalence will be able to really help them and target maybe a specific disease. We don't know. It could be that it's just the increased prevalence in women of the same disease as it also is in men. But if you can find either something specific to help the women, or if you are even luckier, men have the same pathway, it's just not as clear, and we can actually improve the life of even more migraine patients if they share some of the same pathways. And what we know is that when there is a drop in the estrogen levels, the women experience the migraine pain, or the most common migraine trigger is around the drop in the estrogen levels. So it seems to be a strong link to between the hormones and the migraine that many women are experiencing.
I know that it usually comes around the same time as my period, but with migraine you can never be sure. So I always walk around worried about when the next one is going to happen, and because I know my day can just be ruined in the blink of an eye, and I have no way of controlling it. So it's really scary to just know that all day, and I have to avoid all possible triggers. I might miss important classes, or I once missed an important math test that possibly affected my grade.
The hypothesis that we have is that CGRP, as we know, is important in migraine, and that estrogen is leading to this increase in CGRP signaling. But at the same time, we know that estrogen is linked to another hormone, which is called oxytocin, which is also known as the love hormone or the affection hormone, which is also very important in, for example, creating bonds between the mother and the child, but also in just a general a positivity feeling. And what we see is that when the estrogen levels is dropping, the oxytocin level is increasing. And the idea is that maybe this oxytocin signaling, either by itself or with actually adding oxytocin to as a treatment, could balance the effect of the CGRP. So it's also this positive effects of the oxytocin hormone fighting the more negative effects of CGRP. And there are some evidence that, for example, using nasal spray with oxytocin has some preventive effect of migraine attacks.
I have been to several doctors and tried different medications, but none of them have worked for me. So my wish would be to actually find a drug that could work fully and get rid of the migraines completely. I worry about the future and how my attacks will develop. If they become more frequent, that could mean that I lose opportunities, and studying at university, how's that gonna go if I get more migraines? And my work life could also be affected. So it's really scary to think like that, because you don't know what's gonna happen and how they're gonna develop.
We are extremely happy, proud, and really grateful, but also humbled by receiving this prize. And I'm sure I speak for all of us here. We have all been studying migraine for 30 to 40 years, and we kept at it. It was not always easy, because as you have heard in the previous talks and the movie, migraine has been not a very popular subject, to put it mildly. It has been an offer of prejudice, if not complete disregard. There's been literally no basic scientists involved in this field. We are all doctors who have done basic science, but the people who are basic scientists from the beginning haven't paid much attention. Maybe because it's been very difficult to generate funding for migraine research. And this brings us to the question, why? Why has this, and you heard about how prevalent the disease is, how much impact it has. Why has it been looked at like this? And I hate to say this, but I think it is because it's a female disorder. We have a recent paper. We know that there are 2 or 3 females for each male, but we have a recent paper showing females have more frequent attacks, more severe attacks, more difficult to treat attacks. They have more social disability because of their migraine than men. So it's a reality, and fortunately, I think there's a chance it's going to improve. And here, I think that this prize is of immense value. I mean, for us, it's wonderful, but the real importance of the prize, in my opinion, is that it casts a light on this disease. And I think it will demonstrate to basic scientists, to neurologists, and to a wider audience that this is a worthwhile disease. This is a neurobiological disease. We can study it. We can solve some of the problems. There is a light at the end of the tunnel. And I tell you that our patients have appreciated this. And all of us has received numerous letters from patients saying, thank you for doing research on this in my disease. Thank you, because this new medicine has given me a new life.
I think we're just at the beginning of understanding migraine, which I think portends a very bright future. I think the big questions relate to, how does a migraine attack start? What's going on in the human brain at the very beginning of a migraine? And how does it evolve over the different phases of migraine to ultimately cause pain, discomfort, sensitivity to light and sound, the desire to go into a quiet room? What are all of these phases telling us about a migraine attack? And we really just have the very beginnings of the knowledge at the present time.
We are at a remarkable juncture in the history of migraine research. We've gone in a relatively short period of time, maybe 50 years or so, from it being a soft, not particularly interesting, vague pastime, to a biological understanding of what's happening. We've got a great classification. We have an understanding of what's happening in the brain. We've developed new therapeutics on a clear basis with clear targets. It's very exciting because we have the roadmap, we have the possibility. We need to build out the field, which is vastly under-resourced for the size of the problem, and with the collaboration of bench researchers, clinical researchers, and patients, all the important stakeholders, we can make incredible progress in the next decade or so. The future of migraine research is incredibly bright.
För mig så känns det som att man tar en burk med syra och häller det in genom ögat. Det liksom letar sig bak genom tinningen och ner mot nacken. Som att det fräter i hjärnan.
Suddenly I got an enormous headache. It's not comparable to anything. That's why it's called sometimes suicide headache.
The day that we can claim that we can cure migraine attack, it's impossible. It will be utopia. But we can control migraine attacks. We can improve quality of life.